Good afternoon, everyone. This is Bill Gens again with TopSolid'USA. I'm the Sales and Technical Director, and I will be your guide for today's presentation. I believe we're expecting a few more to show up, so I'm just going to give it a few minutes. I see people logging in. As with all of our other presentations, we have my colleagues, Joe Hart, Technical Manager, and Mike Kay, Sales Manager, with us as well. They're paying attention to the questions you guys type in to make sure that we give you guys answers. All right, so why don't we get started, and the rest that are going to join, we'll just catch up. So this is the first of our CAM presentations. This first presentation is all about the U.S. market. Okay, so we have some new standard libraries for the U.S. market to announce. We have a few more that we're hoping to sneak out this year as well, but here we go. So we worked on tooling this year, or over the past 12 months, I should say, for the U.S. market. We worked on some standard methodologies. We worked on some standard generic machine definitions. I'll explain why when we get into that one, as well as a standard materials library. So let's start with tooling, shall we? With tooling, I'm pleased to announce that there is now a standard inch tooling database that you will be able to download and use. This standard tooling database works with CAT holders, not just CAT 40, forgive me. There's 222 varieties of CAT holders in the CAT holder database. There are 2,800 plus tools that we've defined. Okay, and then as far as milling tool assemblies, there's over 2,500 of milling tool assemblies defined. Now, what did we do? We went after all of the standard size tooling that people use and added it into a library for you, so that if you're a new user or an experienced user, you have less work to do to create your own libraries, and you can just get to processing parts and programming your parts, which is why you have this software to begin with. Okay? The added benefit to all of this is A, you didn't do the work, we did, and B, we've also included saved searches for everything that makes it super easy to find, drag and drop, simple to use. What do I mean? It's a good question. Let's go off into TopSolid and we'll have a look. So if I go into my fancy CAD assembly tools, for example, this is just to show you guys what's in here. So I have standard broaches in here. I have all of your standard center drills from 00 up to number 10. I have all of your standard flat drills in here, some basic gun drills, your standard spot drills, and of course your twist drills organized by fraction, letter, and number. Okay? And again, it's just so that you don't have to create these things yourself. Now, this is the library. How do we access the library? Well, let's go into a machining file. Just open up this one here. Why not? We'll go into a machining file and I'll show you a couple ways of accessing tools. So, on the left-hand side of my screen here, you see my saved searches. Saved searches is something that's existed, I want to say, for 4 or maybe 5 years now. I think very few people know how to use them, so it's another reason why I created them. I want you to be aware of the fact that it exists and the fact that it's an extremely powerful tool. The whole idea behind a saved search is to create searches for things you use a lot of. And when you're programming parts, what do you use a lot of? Tools. So for example, let's say I'm looking for a specific drill. I want a fraction drill. So I'm going to double click on my fraction drill. And here, I was messing around with this beforehand, are all of my fraction drills defined, ready for me to use. Okay, so I want this drill here maybe. You can see it here. Perfect. Looks good. I can drag and drop this in, specify which pocket I want to put it in, and it's ready to go. And if I go look in my tool manager, here's that tool. We go look, you can see it's got its default stick out distance. Everything functions like you'd expect it to function. And off you go. Okay? So this is your standard milling tools. If I go look at another type of tool, let's go look at mills, for example, and I'm going to look at slot mills. Now, One thing that you'll have to do on your side is you'll have to tell TopSolid to increase your search result capability, because there's a lot of tools in here. For example, this is a 2-flute, a 3-flute, a 4-flute tool, and I know it's looking at flutes because right here I have a filter set to number of teeth, then cutting diameter, then cutting length. Okay. Down here I can see more results, so I'm going to click that until I don't have it anymore. So there's 237 of these tools. Maybe I'm looking for a 5-flute tool that is a 3/4 inch diameter with 2 3/4 of flute length, right? That's right there. Or maybe I'm looking for a 6-flute tool that's a 1/2 inch diameter with 2 inches of flute length. That's right there. And again, drag and drop it to include it into your CAM document. Okay? All the tools are there. Let's take a look at a few others. If I go back to spot face mills. We have spot face mills. If we go there, I have a high feed cutter or two in here as well. Okay? Just as an example, because there is a plethora of ones out there, but at least you have a working sample of one now. Back spot face mills, lollipop mills. There's a lot of them in there. Let's look for a 1/4 inch lollipop mill. With different stick out lengths. Okay? Perfect. Now, let's go back to our presentation. All right, next. We did the same thing with the turning tool library. Now, we've been working on this diligently, like I said, for some time. We just finished this initial library, so my save searches aren't done yet. They will be done for next month when we look to deploy this, but there's so far 1,237 standard turning tools available in this library. We'll go take a look at them just so you guys can see. And again, these are all standard inch tools. That's the thing that I want to stress the most, is that it's standard inch tooling. Let's go close this one down. Close you down. There we go. Here's my standard turning tools. All right. So if I look through here, for example, we have some face groovers. Okay, and you can see there's a lot of tools that we've added to this. Okay. Now, let's look at how these can be used. So, for example, I'm going to go ahead and open up a little sample file here. Okay. We can get rid of this one. And here we have just a simple little turret base lathe, right? I want to use this same holder type, so I'm just going to control drag and drop that holder type up to pocket 3. That's perfect. And then I'll take this tool right here, why not? Drag and drop it right into there. And if we go and edit the tool, of course, you can play with its stick out distance. So for those of you that have built tool libraries, you know that what I'm showing you is a ridiculous amount of work. And we happily did this to help all of our customers in the US be a little bit more functional and a little faster at what they do. And again, let you focus on the important parts, which is to manufacture parts. Alrighty. Let's keep looking at what other goodies we have for you guys this year. All right, so that's tooling. Let's talk methods. Oh, wait, hold on a second. We have some questions here. Will the database be done for metric tools? There is a basic database of metric tools that exists. Joe is correct. We are discussing with TopSolid SAS corporate in France to create a similar database for metric tools as well. Okay, but our first focus was inch tools because that was a shortage here in the US market. Are the assemblies basic assemblies where the tool body and insert are part of the same tool, or are they inserted tools set up separate insert, clamping body? I'll let Joe answer that one directly to you because he did the turning libraries. But I believe that the answer is yes to that. All right, so I'm going to focus on methods now. So part of the goal here was we're going to deliver you standard inch turning and milling tool libraries. We also want to include you standard out-of-the-box working methodologies. And what is a methodology? A methodology is a piece of machining automation. Our first goal at this is to give you some good working samples and then to progress over time. Okay? So, first off, we did standard drilling and milling methods for inch users. The drilling methods include drilling, tapping, reaming, spot facing. We did standard milling methods, including facing, pocketing, open pocketing, things like that, as well as side milling. I don't have it written there, but it is there. Okay. It also includes standard process documents and standard association documents. And I'm going to explain what all that is for those of you who don't know what they are. Okay. So first of all, in a method, tool sizes are automatically calculated in all methods based on equations or rules. So in this sample, I am showing how a slot mill, that's what you're seeing here, is being calculated. This is for the pocketing tool choice, where we're taking we want the tool diameter to be smaller than the minimum profile radius times 2 plus 1/8 of an inch in this case. Okay? So I'm making sure that we always generate that turn. And then the software is going to filter and find an appropriate tool for you. Okay? From there, an association document. An association document is used to specify for a facing operation, I want to use this methodology. Okay, for pocketing, I want to use this methodology. For an open pocketing, I want to use this methodology. It is applied in a design document. So whether the part is imported or not, you can apply the machining process association here. And then you go into TopSolid'Cam and you run a machining features analysis, in which case it automatically identifies the features that you have already associated. It's already picked the processes that go with it. It assigns the methods to run, you hit calculate, and 12 seconds later, you have 12 wonderful operations where your part is automatically programmed with full automated tool selection. Okay? Now, how does that work? Glad you asked. Let's go give it a go. If I can get out of here. There we go. Save this one. I don't want that one. Sorry, guys. There we go. All right, so let's go to our method preparation document here, and this is just to showcase how things work. Okay, and so what I'm going to do is I'm going to delete that, and we'll start from import. Okay, again, this can be applied to a TopSolid design file, but I'm going to do it from an imported file just to help everyone understand how cool this actually is. So if I go to shape here, right, I've added my machining process icon to mine, and I'm using my boost-based process association document, and I'm going to start with facing. Okay, so I want to face this and this. Perfect. When I do that, you notice it changes the color even. It's just as a way to help identify things. Then for my open pocketing, I want to apply my open pocketing here and here. And then for my pocketing, I'm going to apply it to this face and this face. And oh, by the way, for those of you who haven't thought to ask the question, yes, this works in 5-axis preposition as well. Okay? So we hit save. We've now applied the associations we want. Let's send this off to a machining document. We'll go to my Haas VF6 just for fun. We'll go load this up there really quick. Toss it on my vise. Perfect. Butt it up against there. Close that to there. Fabulous. Now, I'm going to go turn off some of the things in my display, like the enclosure and the ground, just so we can see things a little bit more cleanly. And the other thing that I'm going to do, this template of mine has tools preloaded. Guess what? I'm going to get rid of them all. Okay? We'll hit save. We now have an empty, dumb document with just our cam set up. So now I'm going to right-click in space and go to Machining Feature Analysis. Again, like I said in my little PowerPoint. And now we can organize these things and look at them. So my facing is set to my facing. This face here is set to manual machining because it sees it as a face to machine, but doesn't know what to do with it. I'm going to deselect that because I don't need to machine it because I'm having it machined by the facing up here. Okay. Then we have another manual over here because again, those just weren't assigned anything. And now from here, I'm just going to click okie doke and let the software do what the software does. So now it's analyzing the geometries. It's picking the tools. It's picking the tools based on the geometries even. That's even better. Now, this is just an example of methods-based machining. Our goal is to deliver you guys something that works, something that you can dissect and learn from. Okay? And from here, capture your company's manufacturing methodologies and turn it into a bunch of automation. Okay? And like that, we're done. Okay? All of the methods that I asked to be applied are applied. And now from here, maybe there's a little bit of stuff I need to clean up yet that the methods couldn't see, but it took care of the heavy lifting for me so I can focus on everything else. Okay, doke. So, I see one question on there. It says, can we set methods up to use our own personal libraries when it comes to tool selection, or does it pull from other libraries? I see Joe answered something. He said, these standard methods will not reference other tool libraries. They would require modification order search. So, in fact, I'm not picking any specific tools from any specific libraries. In fact, what it's doing is based on what tooling libraries are referenced, is what tools it's going to search. If it cannot find a tool, then it's going to pop up and warn you and say, hey, no tools found. You want to create a new tool. Okay? So all of the libraries that I created, I'm not specifying any specific tool. I may specify a diameter of a tool that I'm looking for, but again, it's going to look based on your references. So it is as useful as possible out of the box. Cool. Alrighty, let's keep going here. I'm going to go back to my presentation here. Next, let's talk about drilling methods. So, forgive the part's boring. It's just a sample to test drilling methods on. But the drilling method includes automatic tool selection, of course. For example, holes that are greater than 5/8 will include a pre-drill operation with a 1/2-inch drill. I was just referencing this before. Okay? And I'll show you guys a little bit of how that functions. In this sample, 33 operations are created in 4 seconds. 21 tools automatically selected. That's pretty awesome. Let's go take a look at it. So we'll close this down. And 1 second while I find what I'm looking for. Perfect. All right, so here's my drilling test. Again, here's that, right? I'm going to select everything, delete it. I'm going to go to my equipment tab, select everything, delete it. Again, the method's going to search in your tool manager first for a tool. If it doesn't see one there, it's going to pull one from the library. Okay, so if you have your template set up with standard tools, it's always going to grab your standards first. All right, so we have all these different size drillings, right? Just for good nature here, let's go ahead and go to machining feature, analysis of drilling and cylinders. Here you can see it's found everything. All I gotta do, select it and hit go. And now you get to have a cup of coffee while it does all of that machining. Now, on the drillings, what I did was a little bit different. So, I did some tests on fraction drills, number drills, letter drills. I have my little countersinking operations being done here. So I'm adding champers to everything, of course, and it's auto-calculating based on the hole diameter and what have you. But on the bigger diameter holes, remember I said if the diameter is greater than 5/8 of an inch, right? So this diameter is 0.6562. So if we come on down, Here it included a pre-drill with a standard 1/2-inch drill. In the methodology, I'm just specifying to find a 1/2-inch diameter drill. I'm not specifying which tool library to pull it from. So again, this should work on anyone's library, provided you have a 1/2-inch drill defined in your library. All right. And then again, same thing for these big holes here and here. And then we come back in with the on-size drill. Again, 4 or 5 seconds to calculate. All those tools created. What's not to like? Back to our presentation. Next, tapping. So again, similar automatic tool selection. In this sample, 22 operations, 21 tools automatically selected. Roughly about 2 seconds to calculate. So let's go have a look. We'll go look at tapping. Again, I'm going to delete everything. We'll go back to here. Delete all of our tools. And we'll run our analysis of drillings and cylinders. Everything's ready to go. Boom. So one of the questions is, can it be intelligent enough to pick fully defined tools with fully assembled tools versus just stick tools? The simplest way is to not reference your stick tool library. Your stick tool library is referenced in your assembled tool library. And I can explain that in a second. More in depth, let me finish this. So again, all your drilling, all your tapping tools done. This one, as you can see, just a couple seconds, 21 tools created. Why so many tools when there's only 22 operations? Because again, some of these holes are bigger than 5/8 of an inch, so it's pre-drilling a hole. It's using the same drilling methodology I used before. Okay. Now, real quick, if I go to my cat assemblies, and actually we can just pull it up right from there, just to answer this question really quick. So this is my library of assembled tools. That's it. So I'm referencing the library of assembled tools only in this operation. Okay. In this library, I'm referencing my stick tool library. So this is all the individual cutters now as families. Okay. So I reference this in this library. This library is what's referenced in the actual machining file because I don't like to use stick tools by themselves typically. Hope that makes sense. Okay, so let's keep going. Got one more sample for you when it comes to methods. So I did one more. I skipped over reaming, but reaming is the same. Okay. I'm going to the spot facing because I did something interesting with spot facing. So with spot facing, again, automatic tool selections, but in this case, different types of tooling for different size spot facing. And what do I mean? Here, you can see that we're plunging. Here, you can see that we're side milling or pocketing. Okay, 17 operations, 13 tools, 4 seconds to calculate. Let's have a look. Back to that again. Okay, so let's go to our spot facing. And I'm going to simulate this one as well, just to, again, show you how smart you can make things in here if you really want to. Okay? Alrighty. Boom, delete. Let's save. We'll go back to that analysis of drillings and cylinders. Select everything. Looks good. And off we go. So again, now what this is doing, of course, it's going to, center drill and drill the holes. It's going to then counterbore or spot face all the spot facings, and it's using standard tooling to get there. Okay, and it's also using different types of operations. So again, this was 4 seconds to do all that, right? So let's go into, let's just do these spot facing simulations. I think spot facing, spot facing, spot facings. Yeah, I like that. So we'll come here. Now, what do you notice? It's actually a good old-fashioned counterbore tool that's got the little nip on the end of it. So it's taking that into consideration as it's creating all of these operations. Boom. Of course, you could tell it to use a flat bottom spot facing tool as well. I just did that for fun. And now these, because they're a specific size, they're larger. You can see I am just machining this with an end mill. Okay. So again, awesome example of automation. This will be nice out-of-the-box performance improvements for all of you guys. All right, let's go back. From here, generic machines. What are they? Why do you care? All right, so over the years of deploying TopSolid to different size organizations, I saw something come up that was hard to overcome, and that is sometimes people don't want to buy the 3D machine definitions, okay? Or they don't want to learn how to create them themselves, and then it creates kind of a disconnect at times in the software, because for those of you that are super familiar with TopSolid'Cam, we do best when we're on our 3D machines, right? Because our CAM software really uses a lot of the information that's present in the definition of these machines to help make good toolpath. So one of the things that I decided to do was create a standard library of generic machines. And my primary purpose for this is for educational purposes first, okay? I want to give people standard kinematic type of machines that they can work on while we're developing their machine definition for you, okay? Or maybe this is good enough for them. They don't care that it's not exactly perfect to their machine. It's enough to get the calculations correct, okay? So it can save customers a little bit of money. Now, it's up to you to determine if this is important or usable for you, but I think for the educational side of things, when you're teaching someone something, I think this is a great beginning way, and it's kind of a step above the universal machines that ship with the software. Anyway, as you can see, I have a standard 2-axis lathe in there, X, Z, and a C. I have an XYZ lathe in there as well. Again, this is as complicated as that machine definition looks. You have a turret and a spindle for your chuck. Your 3-axis mill looks just like this one, just without the rotary. All right, your 4-axis mill, we have a couple of difference with 2 horizontals and 1 XYZ plus a side-mounted rotary. And then, of course, we have some 5 axes with trunnions on it. Okay? And they're with or without plane rotation activated. So it's an educational thing, maybe something that can be used by some of the smaller shops out there where they want this, but they don't want to spend the money on the official machine definition. It's just a way to help keep things moving forward for everybody. So we'll get these out to you guys. You guys can play with them, see if they're useful to you. All right, last library that we're going to talk about is a material library. Okay? Now, again, this comes with the standard save searches. The standard library that ships with TopSolid is a great library. Unfortunately, it uses European nomenclature for all the names of materials, which none of us know. This means that no one here in the US is going to use them. So what we did is we talked to a bunch of customers, we found out what type of materials they use, and we added about 60 commonly used materials. Okay? They're all accessible by just going straight to the library or by using your save searches. For example, you can say, I want titanium alloy. It shows up in the search result like it did with my tooling. You drag and drop it onto your document to apply it, and off you go. In the future, we hope to add some other standard libraries, such as feeds and speeds libraries, which will be tied to these materials properly as well. So we're going to be continuously working on these types of value-added items on the months to come. Okay? With that said, that is the end of this presentation. So let me look over to the questions. I saw lots of questions come up. Is there anything that was not answered? Or does anyone have any new questions? Don't worry about the person saying they can't let their boss know that this works this quickly. You'll be out of a job. Nah, you'll just program more parts. I know your owner. You're safe. Alrighty. Does the method automatically choose interpolation versus dedicated spot face tool based on the availability? So I suppose you could set up a rule that way. For me, I set up my rules for the spot facing based on sizes, because the standard spot face tools only go up to a certain diameter, and then you switch to an end mill and interpolate it anyway. Some people interpolate everything. So, you could go into the method I have, copy it into your own library, and just delete the section that grabs the nub face spot face mills. So at the end of the day, you should be able to get to your finish line. Again, these methods are not going to be perfect for everybody. The goal of them is that you have working examples that work with inch tooling, works with inch values, and are efficient and created correctly following how methodologies are supposed to work. From there, make copies of them, pick them apart, see what you can do with them. I'd love to see samples you guys put together for your own shops and what you can automate in your manufacturing process. Cool. Does anyone else have any questions? If not, I hope you all enjoyed this first look at TopSolid'Cam for 2022. We didn't really show much cam. In fact, we showed just some things that needed to be done for this marketplace first. So starting tomorrow, we're going to start into the actual cam operations. The first one tomorrow at 9 a.m. Central Time is to go over drilling improvements. At 11 a.m. then is 2D milling, 1 p.m. is 3D milling, and at 3 p.m. tomorrow will be 4D and 5D. I hope you all have a nice evening, and we look forward to presenting to you tomorrow.